Our learning this week is going to be focusing on Unit 7, Lessons 4, 5, and 6. So Lessons 1, 2, and 3, we worked on expressions and simplifying and evaluating them. Now, the second half of Unit 7 is a little bit different. We're going to be looking at number, patterns, and sequences. And then the other thing that we're going to look at that lumps together are coordinate planes and grids, and then ordered pairs. Which, looking at these words like this, you might be like, I'm not quite sure what that is, but I think once you actually see it, it will look a little familiar to you. So first, we have in Lesson 4, patterns and expressions in numbers. So a numerical pattern, numerical is a fancy way to say number. Let me turn this on. Maybe that'll make a difference. A numerical pattern is a sequence of numbers that share a relationship. Each number in the numerical pattern is a term. So here we have this number here is a term. Below we show you the first 5 terms of a pattern. 3, 5, 7, 9, 11. Think about the pattern and how it gets from one term to the next term. It's the same jump between terms. The pattern above starts with 3, and then each term is 2 more than the previous term. So 3 plus 2 is 5, 5 plus 2 is 7, so on and so forth. So here it shows us ways that you could write this as an expression. So we have 3, we add 2, there's 5. We add 2 again, so 3 plus 2, we get 7. We add another 2, we get 9, and we keep going. So they show us here using it with parentheses because it's 3 plus 1, 2. So 1 times 2 is 2. So it's just like 3 plus 2. Now we have 2 2's. So it's 3 plus the product of 2 times 2, which is 4. 3 plus 4 is 7. Now we have 3 plus the product of 3 times 2, which is 6. 3 plus 6 is 9. See how those work? So now it says, write 2 expressions for the next term, or the 6th term. So these are the first 5. We want to know what comes after 11 in the pattern 3, 5, 7, 9, 11. So one version of this could be, so we have 3, we're adding 2, we're adding 2 again, so that's 3, 5, 7, 9, 11. So to get the next term, we would have to add 2 again. That's a very long expression. So a way that we could do that, which will mean the same thing, is to say 3 plus the product of however many 2's we have times 2. So we have 1, 2, 3, 4, 5. 5 times 2. Both of these expressions simplify to the same thing and tell us that our next term will be 13. You might have been able to get that a little faster just by saying, okay, we're going up by 2's. 11 plus 2 is 13. All right, now it wants us to write the pattern. Write the first 5 terms of a numerical pattern that begins with 5 and then adds 5. So term 1 is 5. And they're saying to get from term 1 to term 2, we have to add 5. So 5 plus 5 is 10. We have the first 2 terms. We have to add 5 again. Add 5 again. Add 5 again. So you'll notice that this pattern or sequence is just having a skip count by 5's. Now it says, write an expression for the 6th term of the pattern. It's the same thing as this one up here. So we could write it out as all addition, or we can use less digits and use our parentheses. So we could say, okay, it's 5 plus, well, we're going to need, we have 1 plus 5 once, 2, 3, 4 times. So we're going to need a 5th. 5 times 5, because we need 5 5's. And what is that equal to? 5 times 5 is 25. plus 5 is 30. The other way we could have written it is 5 6 times. 5 plus 5 plus 5 plus 5 plus 5 plus 5. But that is just a lot of writing. So this is an easier way or a simpler way to write that. So it told us to start with 5, and then in order to get to the next term in the pattern, to add 5. So it told us how to get there. The second part is it wants us to look at patterns, like we did before, and the relationships between those patterns. So, for example, it says, write the first 5 terms, and it gives us the spaces to do that, of a pattern that begins with 2 and then adds 2. So I begin with 2. To get to the next one, I have to add 2. To get to the next one, I have to add 2 again. So we're really skip counting by 2s. Let's look here. Write the first 5 terms of a pattern that begins with 4 and then adds 4. So we're just going to make our pattern again. 4, we have to add 4, so 4, 8. So we're skip counting by 4s. 4, 8, 12, 16, 20. You'll notice now, I'm just going to get rid of this here so it's more clear. This looks kind of like a fraction. So it says circle the corresponding pairs of terms in the patterns. So it wants us to circle these corresponding pairs. So those are our first terms, our second terms, our third terms. We're circling them and they look like fractions. It says, how does each term in the top pattern compare with the corresponding term in the bottom pattern? So how can we compare 2 and 4? Well, 2 is half of 4. Let's see if that's true for the other ones. 4 is half of 8. 6 is half of 12. 8 is half of 16. 10 is half of 20. We could go the other way and say 4 is 2 times 2. 8 is 2 times 4. 12 is 2 times 6. So I'm going to say the top term is half the bottom term. And since we used the same way to get to each of these next terms, that pattern is going to be true for all of these. Because for all of these, we skip counted by 2, and then for all of these, we skip counted by 4. How does the bottom term compare with the top term? Well, the bottom term, like we said before, is 2 times, I'm putting an X for times, the top term. Whenever you compare things, you can always compare things 2 ways. Lesson 2 has us looking at patterns and relationships in numbers, but now it has us looking at real-world patterns and relationships. So it says, many situations in your everyday life can be described by numerical patterns. Again, numerical means number. The table below shows late fees for an overdue library book. Complete the table. So here's our title, Overdue Book Late Fee. We have our 2 categories. The number of days late, which is filled in, 1 day late, 2 days, 3 days, 4 days, 5 days late, and then the late fee. After 1 day, the late fee is 15 cents. After 2 days, the late fee is 30 cents. So what is the relationship? So the day increases by 1. What is the relationship between the late fee? How does that increase? Well, how do we get from 15 to 30? We add on 15 cents. So it's an extra 15 cents because 15 plus 15 is 30. So then, if we have it 3 days late, the day increased by 1. First it was 15 cents, or 15 times 1, or I'm sorry, 0.15 times 1. Then we have 0.15 times 2, 0.15 times 3, or just adding another 15 cents is 45 cents. Then we add another 15 cents for 4 days, that's 60 cents. And last, we add another 15 cents, which is 75 cents. If you look here, what do you notice about this number set, 1 over 15, and this number set? Think about what you know about fractions. How are 1 over 15 and 5 over 75 similar? Well, I'm going to write it as a fraction. 1/15, 5/75. This is a unit fraction because it has 1 on top. That can't get any smaller. Can we simplify 5/75? Yeah. 5 divided by 5 is 1. 75 divided by 5 is 15. So these are equivalent fractions. So per each day late, it's an extra 15 cents. 1 day late, it's 15 cents. 2 days late, it's 30 cents, so on and so forth. So when it says describe the relationship between the corresponding terms, you could say, well, let's see. This is 15 once. 1 times 15 is 15. 2 times 15 is 30. 3 times 15 is 45. 4 times 15 is 60. 5 times 15 is 75. So we could say the relationship is the number of days times 15 cents, or you could say add 15 cents for each day it's late. They mean the same thing. So this is just like what we had here. These, if you looked at them as fractions, were all forms of 1/2 because we skip count the same for the top and then we skip count the same for the bottom. The same happened here. We went up by 1 and then we went up by 15. Now we are shifting from number patterns and sequences to coordinate planes, which look like this. You should look at this and say, oh, I think I've seen that before. It looks kind of like a graph. Or if you've done the coordinate plotting pictures where you're not sure what the picture is and you plot it and then connect the dots, this should look familiar to you. So as you can tell, there's lots of vocabulary words involved. That's why it's important that you study the Quizlet. So it says a coordinate plane is formed by the intersection of a horizontal number line called the x-axis. So this line here, horizontal means side to side. So this is the x-axis. And a vertical number line called the y-axis. So the y-axis goes up and down. So when the y-axis and the x-axis meet, they make this coordinate plane here, okay? Use the coordinate plane below to answer the questions. An ordered pair is used to describe the location of any point on a coordinate plane. An ordered pair always is x, y. So that looks a little confusing, but it just means that first you write the number on the x-axis, and second, you write the number on the y-axis. So, for example, the ordered pair 9, 5 describes the location of point A. So here is point A, 9, 5. So that means that first you do your x-axis number, you go over to 9. Second, you do your y-axis number, and you go up to 5. And that's how you find it. You go over and then up. So over 9, up 5. That's what this means. An ordered pair consists of an x-coordinate and a y-coordinate. So this is our x-coordinate first, or over, and then our y coordinate second, which is our up. The first coordinate, the x coordinate, represents the distance along which axis? It is the x-axis, which is the horizontal axis. And I'm going to draw arrows going left to right. So it's this axis down here. The second coordinate, the y-coordinate, represents the distance along which axis? The y-axis, which is the vertical one. Vertical, I'm going to draw arrows this way, goes up and down. Last vocabulary term, the origin of the coordinate plane is the point 0, 0. The origin is always 0, 0. So it's this spot right here. You go over 0, you go up 0. It's right here at the corner. Why is the origin an important point? Because you always begin at the origin. So what I mean by that is when we plotted 9, 5, we didn't start over here and go over 9, up 5. We didn't start here and go over 9, up 5. You start at the origin, 0, 0. You go over 9, up 5. That's why it's important to know where the origin is. It's usually right down here in the bottom left. Okay, now it wants us to label our ordered pairs. Write an ordered pair to represent the location of each point. So first we have point B. See if you can figure out what the ordered pair would be. It goes X, then Y, or over, then up. So point B is over 3, so it's 3, comma, up 3. So the ordered pair is parenthesis 3, comma, 3, close parentheses. Point C, let's see, here's C. Point C is over 9, up 10. So it is 9 on the x-axis, 10 on the y-axis. See if you can figure out what the coordinates of point D right here is. The coordinates of point D, we go starting at the origin, over 8, up 1. See how our axes are labeled? Point L. Point L is an interesting one. Starting at our origin, how much do we go over? 0. We do not move on our x-axis. It stays at the origin. So over 0, up 7. So 0, 7 is our point. Pause the video. See if you can find the coordinates of point M, point N, point R, and point S. Go ahead, pause the video. All right, so for point M right here, we go over 6, up 5. So it's 6, comma, 5. We separate them by a comma. Point N, we go over 5, and then we do not move up on the y-axis. So it's 5, comma, 0. Point R, we go over 2, up 6. So it's parentheses 2, comma, 6. And last we have point S. Point S, we go over 7, up 8. So it is parentheses 7, comma, 8. Now, you won't get a chance to do this week because you need pencil and paper to do this, and I can't assign you something like that. So I'm just going to show you quickly. Here's a coordinate plane. We have our x-axis running this way, our y-axis running this way. Here is our origin. That's where we start at 0, 0. I'm just going to plot a few points just to show you. So here it says point J, so I will label it J once I put it there, at 5, 4. Remember, it's x, comma, y. So 5, 4 means over 5, up 4. So where these two lines meet, that is point J. Here it says, number 12, point Q at, and this is the location, 1, 9. So X, I go over 1, and then I go up 9. Where the two lines meet, I put a dot, and I label it Q. Next, point Y at 2, 0. So that's over 2, up 0. So I put it right where those two lines meet, and I label it Y. So it's always sideways, then up and down. That's how you plot points. Okay? And moving on, the last thing we're going to look at, because since it's so hard for us to plot when we're doing it on the computer, I'm just going to show you how to do it. So this is how we take our understanding of patterns and sequences and put them on a coordinate grid. So here we have a table. We have age, so the label is the growth of a shrub. We have the age of the shrub and how many feet it's growing. Our pattern here is it increases by 1 for every year. So year 1, it's 1 foot. Year 2, it's 2 feet. Year 3, it's 3 feet. This table right here actually gives you the ordered pairs. So this, remember it's always x, y first. This is our x coordinate. This is our y coordinate. So the 5 ordered pairs that we have, let's read the table, 0, 0. Then we have 1, 1. And so on, 2, 2. 3, 3, 4, 4, 5, 5. Now, the reason that I wrote the 0, 0 is because that's the origin. So when the tree or the shrub is 0 years old, of course it is 0 feet tall. So I put a dot right on 0, 0. That's our origin. It says graph the ordered pairs and connect the points. So now we're turning this coordinate grid into a graph. So we plot age is on our x-axis, height is on our y-axis. So now we just plot them. We put 0, 0. Next we have 1, 1. That means over 1, up 1. 2, 2. Over 2, up 2. 3, 3. Over 3, up 3. 4, 4. Over 4, up 4. 5, 5. Over 5, up 5. You should see what kind of line it makes. Then it says connect the points. It's good to use a straight edge to connect the points to make sure that your line is straight. I connected my points. What does each axis on the graph represent? Well, we have age is the x-axis and height is the y-axis. So as the shrub gets older, it gets taller. For each 1 year it gets older, it gets 1 foot taller. And finally, working in the opposite direction, if they give you the coordinate plane labeled with plots already pointed, or put there, we're going to work backwards and identify the ordered pairs. So first down here, I see a dot right at our origin for 0, 0. It's important, again, to identify where the origin is because that's always where you're starting from. 1 second, I just want to see if they write that one down or not. I'm not sure if they do. They do write that one down. So we have 0, 0. It already has the comma and the parentheses. Next, right here, here's our point. First I go over, it's over 1, up 2. See how on this one, they don't label every single line on the x-axis. So you have to make sure that you're reading it correctly. So it's over 1, up to what? Not 2. It's up to 60. So it's 160. It's not 1, 2. You have to make sure that you're reading it correctly. So this goes up 30, 60, 90, 120, 150, 180. This skip counts by 30s. This goes up by 1s. So we have 0, 0, 1, 60. What's next? We have 2. How far up does it go? 120. So 2, 120. Let's look at this third one here. Goes over to 3. It goes up to 180. Complete the table to show the relationship between time and distance. Okay, so time, hours, that's looking at our x-axis. Distance in miles looks at our y-axis. So time and hours goes 1, 2, 3, 4, 5. Okay, so 0, 1, 2, 3. It only wants us to go up to 3, so that's all we'll go up to. And the distance in miles, so that's just looking at what we had for the y-axis. So when we had 1, we had 60 miles. When we had 2 hours, we had 120 miles. And when we went 3 hours, we went 180 miles. So that's how you work in 2 directions. On your homework, you're going to have to read a labeled grid that looks like this. Remember, you read X first, then Y. Don't just count the lines, because if you were counting the lines, you would say, oh, 1, that's 2. But you have to read how it's labeled. So the 1 line is actually the second one in.